Hello everyone. So today I'll be talking about the second task, that is the unemployment analysis. I'll walk you through the code explaining each step and the underlying concepts. So let's go. So first we import all the required libraries. Pandas for data analysis, NumPys for data analysis, Matplotlib for data visualization, Seaborn for data visualization, Plotly Express for data visualization, and just warnings if Seaborn throws any. So the next step is that we read the CSV files. There were two files provided. So we can see the data by first region. Region here is the state's name, the date-wise data, the frequency if it's male or female, the unemployment rate in percentage, the number of people employed, the labor participation rate, and region dot one indicates the area as per the directions, that is north, east, south, west, and the longitude and latitude. Head just checks the first five uh, rows. Then the data types is to check what uh, data type they belong to, and describe is just to understand the basic idea of it. So we can understand that the average mean unemployment rate is 12%, and yeah, the other things are also there. Like the minimum is 0.5%. Yes, so let's go ahead. We do data.info to get the data type of each and every column. And here we can see that the the percentage rate is float, the labor participation rate is float, and the longitude latitude is for float. Okay. Next, if we need to first check whether any of the column contains null values, that is, if it contains zero, then we need to eliminate. If the number of zeros or null values are large, we can just eliminate that column because it will be of no use in our data analysis. Next, we plot the bar chart for estimated unemployment rate by region. In this code snippet, we use matplotlib to create a visually appealing bar chart. The x-axis represents different regions, the y-axis shows the estimated unemployment rates, and each bar corresponds to specific region. This gives a quick overview of how unemployment rates vary across different regions. And we can see that Puducherry has the highest unemployment rate, followed by Karnataka and and Telangana, but we can't make decisions based on this because Puducherry compared to its uh, area, the unemployment rate is shown. So we can't just judge any of the states just by this. So we need to see the other visualizations as well. Next is the pair plot and histogram. Um, we are using Seaborn again to create a pair plot and histogram. The pair plot showcases scatter plots for multiple variables, helping us identify patterns and trends. So we can see that the estimated labor participation rate and the latitude are kind of related, not highly related, but yeah, it's kind of related, and as well as the longitude is related to the unemployment rate. So we can say that the location of the particular state matters. Okay, let's go ahead. Yeah. So here, this was the correlation chart, and now we'll see the pair plot. In this pair plot, um, it shows us scatter plots for multiple variables. So the histogram colored by different regions. So I have given the U as region one. So of course, if you remember, region one was uh, the directions south, northeast, east, west, north. So it gives us the distribution of estimated employed values, offering insights into the employment landscape. As you can see that here, yeah. So these the But when we divide it by region, they are getting it into clusters. I hope you can see this cluster. This is one cluster over here, this. So we can see that it's not getting linearly related to each other, but we can see that they are uh, getting into clusters. That's what we can observe over here. Next, yeah. So we'll have a bar chart again. So on the x-axis we have estimated employed people, and uh, on the y-axis we have the count. So how many people are from, when we have given the U as the region again. So want to understand how many people are employed right now. So as we can see that the north region has the most employed people, and yeah, that's a good sign that we can understand is that the unemployment rate must be low in north region. Okay, yeah. Okay, as we progress, we have this next visualization. On the x-axis, we have dates, and on the y-axis, we have the unemployment rate. So this shows the unemployment rate over time. As you can see, this is the COVID period. Hi, yeah, you can understand, right? Yeah. Um, The x-axis represents time and the y-axis shows estimated unemployment rate, and each line corresponds to a specific region. We have added shaded rectangle to highlight the impact of COVID-19 on unemployment rates during the specific period. Yeah, so yeah, I hope you can see that the unemployment rate was at peak in the month of April 2020. And yeah, we have created this visualization using Plotly Express. And this is the code. Yeah. Okay. Now the next is to understand the impact of unemployment rate on time. But this time we are considering the states as well. I mean, this is a dynamic visualization. This is again created using Plotly Express. So here is the bar chart. This is just to give a bit uh, visualization, like improved visualization, and this is to add the annotations that we can see over here. Yep. And so I'll play this. As you can see, over the time it shows which state had the most unemployment rates. So if we start from here, Tripura had the maximum unemployment rate, 32.67%. Then again Tripura again, and then it was Puducherry in April. Then in May it was Jharkhand, and you can see that the unemployment rate was at its peak during this period. Next, as the COVID lockdown was it was open, people started working in offices. It was allowed, and then the unemployment rate started dropping. You see, so this was a dynamic visualization created by Plotly Express. Next, I observed one thing that the dates weren't perfectly aligned, as in it was in this format and not in the date time format. So I tried to converted it into using the to date time function into the regular date time data type. So yeah, this is it. By using all these visualizations, we have understood that how unemployment rates change across different regions over time. The animation provides a clear picture of the temporal evolution of unemployment rates. In conclusion, our analysis covers a broad spectrum of visualizations, from static charts to bar charts and heat maps to dynamic ones like the animated bar charts. Each visualization technique contributes to our understanding of the data set and the impact of external factors such as COVID-19 pandemic on unemployment rates in India. Thank you.